how are you? We want to continue our lesson, lenses, lesson 31 or chapter 31, lenses. I hope that you understood the first part of the lesson and you studied it. Before you continue watching or before you start watching this video. Now, today we want to continue what we started the previous time. At the end of the previous video, we watched two YouTube videos explaining, first of all, how to find the focal length. Okay, the conclusion. What did we do the previous time? We said that rays coming into a lens from a distant object are almost parallel and form an image very close to the focus. Okay, to find the focal length, the first thing we have to do is to bring a very distant or far object. Look how the object is far away from the lens. Why we have to do this? Because the rays, until they reach the lens, they will reach at what? Parallel to each other. Now from the source, they are not parallel. But because the distance is so far, that's why when they reach the lens, they will come parallel to each other. Why do we want them to be parallel? Because we said before, when lines reach the lens parallel to each other, they will refract and bend and meet at one point. We said we call this point what? Principal focus. Okay, principal focus. So we want to determine the focal length. That's why we want the lines to be parallel. Then we can then measure the distance from the lens to image to determine the focal length of the lens. We just measure this distance from C, the center of the lens, to the point. Then what do we know that this is the focal length? Good. Now we want to start with the most important part in this lesson. What is it? Ray diagram. Why it's important? Because always in your exam they ask you to draw a ray diagram of a lens. Okay, let's understand and to see step by step how to draw an image formed by a lens. Okay, first of all, we know what are the most important things you have to draw them before at the beginning when you start. Number one, the lens. Girls, listen to me. Sometimes we draw the lens like this, but most of the time we just draw it as a line, okay, with two arrows up and down. As what? A line. To make it easier for you, okay? The second thing we want to draw the principal axis. Here is it, the horizontal line that meets what? With the center of the lens. Then you draw what? The two foci. We said that they have the same distance from the center of the lens. Then what do we draw? Let's see, step by step. The first thing, here we have an example. Here is the object. If they ask you to draw a ray diagram, we have three rays, three important rays. Hello, we know that from the object we have millions of rays. Okay, but we just want three of them. These are the three rays that we want to study them and understand them. Number one, the first ray, you have to draw it and use it always from the top of the object. You draw a straight line passing through the center of the lens. And what happens to it? Look, it continues moving in a straight line. No refraction, no bending for this case. Only for this case. When the line moves straight, passing through the center, it will continue moving in a straight line without any bending. Okay, this is the first ray. You have to draw it. Standard ray 1 passes through the center of the lens. Okay, the second one. The second ray is what? Parallel to the principal axis, the same from the top of the object, parallel to the principal axis. Then at the end, when it reaches the lens, what do we do? It bends and it has to pass through the principal focus. Okay, this is the second ray, parallel until it reaches the lens. After the lens, it will refract and pass through the principal focus. Third ray, the opposite of the second ray. How? From the top of the object, passing through the principal focus here, then after the lens, it will become parallel to the principal axis. Okay, because these three rays you have to memorize them. That's it. To know how to draw a ray diagram, you have to memorize them. So the first one, all of them, now number one, all of them from the top of the object, we draw them. Number one, the first ray, parallel, then what? It's refract and bend and enters the principal focus. The second one, it moves straight without any bending, without any refraction until to the second side of the lens, until it reaches the second side of the lens. The third one passes through the principal focus. Then after that, it refracts and bends parallel to the principal axis. Now all of them, they will meet at a point. All of them, they will meet at a point. We are going to talk about this point. Here you will see the image. We are going to talk about this now. The next slide. Is it clear? Let's see. We have so many cases for image formation in a converging lens. So formation of image in a converging lens. The first case, if I have an object beyond 2f. Again, look how they drew the lens. I told you sometimes they don't draw it as a lens, a real lens, just a line or two arrows, okay? If I have an object, it is beyond 2f. You remember principal focus, and 2f is it's double the distance of f. Yani if c to f it is 4 centimeter, from f to 2f also it is what, 4 centimeter. So from 2f to c it is 8 centimeter. So if I have an object beyond 2f, here I know where is 2f, I put an object here. What will happen to the image of the object? Let's see, look. Hello girls, I want to tell you, I gave you 3 lines, okay, 3 rays. You have to memorize these 3. But in the exam, you have to use 2 of them, any 2 of them. Most of the time, you use these 2. The one that is parallel, then enters the principal focus, and the one that is moving in a straight line. Okay? So here, to find the image, what you have to do? Draw line from the top, a line that is parallel to the principal focus, then bends. No need to measure angles here, girls. Okay, no need. Just it bends and enters the principal focus. The second one, it moves straight until it reaches the point of the first one. So here the point of intersection of them. Here is the place where the image will form. Now this point, it is the head of the object, the top of the object, because here we started from the top of the object. Okay, so at this point, it is the top of the object. Look, the image is what? It is inverted, right? Look, it is inverted, not upright. It's upside down. This is number one. Number two, where is the location of the image? It is between 2f and f. Here, it is beyond 2f, the object, but the image is between 2f and f. What also? It is a real image. You remember before in the lesson of plane mirrors, we said that in plane mirrors we have a virtual image. Some girls asked me, teacher, what's the meaning of a real or virtual image? We said a virtual image, it's the image that we cannot see it in a screen. If I put behind the mirror a paper, for example, you will not see the image of the object on the paper. Okay, here in this case for lens, no, we have a real image. Why? Because if I bring a paper here, I will see this image on the paper, so it is a real image. Okay, the last thing, that it is smaller than the object. These are the properties for the first case. Also here you have to memorize these cases, girls. Okay, this is the first case. The second case, if the object is between 2f and f. Okay, the object is between 2f and f. The same, we draw the two lines. The point of intersection is here. What do you see? First of all, the location of the image is where? Beyond 2f. In the previous case, it was here between f and 2f. Here, it is beyond 2f. It is real. If I put a screen, I'm going to see it. It is inverted, but here it is what? Larger than the real object. Here is the object, here is the image. The image is larger. This is the second case. The third case now, if the object is at 2f, the object is at 2f, for example here, what you will see? You will see that the image also where it is at 2f, it is real for sure because we can see it on a screen, and it is inverted, but here what? It is at the same, it is with the same size of the object. Okay, this is the third case. The fourth case, and it's a very important case, focus to understand. Now, if I put the object between f and the center of the lens, okay, and it's so close to the lens. Okay, let's draw the two lines. Here is the first one, and here is the second one. Where is the point of intersection between them? We don't have. You continue drawing till the end, till infinity. They will not meet at all. Where they will meet? The extended rays beyond or behind the lens, they will meet at a point. Here is the point. They will meet here, but they will form what? Who remembers when the dashed lines or the dotted lines meet? These are not real rays. They will form a virtual image. This is not a real image. The same as mirror. If I put a paper here, I'm not gonna see the image. Okay? Here the image is behind the object. It is virtual. It is erect, it means it's upright, not inverted, and it is what? Larger than the object. Okay? Girls, these four cases are very important as I said. Let's see some applications for each case. The first case, you remember, if object is beyond 2f, like here, what happened? It's real, inverted, smaller, it's between f and 2f. Okay, where do we have these lenses? We have them in cameras and what? In the human eyeball lens. This lens inside our eyes, it is what? The same as this case. Okay, the second example, if the object at 2f, the image is at 2f, same size, inverted, and real. These are the properties. We have this lens in a field telescope. We call it a field telescope. Inside it we have so many lenses. One of them is in this case. Okay, when the object is at 2f, we use it in this case. Object between 2f and f. Look, the image is beyond 2f, larger, inverted, and real image. In this case, we have it in projectors and in microscope. The last case, the one that we said larger, when it is the object between the center and the focal point or principal focus, the image is what? Larger, erect, upright, it means, and virtual, and what also? It is behind or at the same size of the same side of the object. Okay, where do we have this case? In a magnifying glass. The lens of a magnifying glass we have this case.